OK, that's it for implementing TLS. So the rest of today is all about how you actually use TLS in practice. I find this section kind of cool because it starts to show how real-world problems like politics and business also influence how TLS is used. So this is more of an overview section on how you implement TLS in real life. All of the theory behind TLS is done. And now we see what it takes to actually make the whole world use TLS and make it scalable. So that's today's goal. So before we do that, here's a bunch of properties about TLS that it provides. So one thing we should ask is how efficient it is. Is using TLS much slower than using TCP? Is that something we have to worry about? Well, here's the analysis. So if you think about the TLS handshake, it does have some public key cryptography. Namely, you have to perform that Diffie-Hellman key exchange, which means you have to do exponentiation mod p. So that's a little bit of extra cost. It's not something that most people notice when they browse the internet. It's probably like a couple milliseconds. But technically, there's some non-zero cost to performing Diffie-Hellman key exchange. Now, what about the symmetric key cryptography, where you're encrypting and decrypting all of the data that you send? Now you are encrypting and decrypting everything. But remember, we've said that symmetric key cryptography is extremely fast on modern computers. Modern computers are actually designed to be really good at symmetric cryptography. Hardware chips have specialized hardware to make encryption and decryption really fast. So nowadays, if you use symmetric key cryptography to send and receive data over the internet, you're basically not going to notice the performance impact in any common use that I can think of. So technically, it's extra work. But as someone browsing the internet from day to day, you're never going to notice a slowdown because you're using symmetric key cryptography. That's why we say it's basically free. So TLS does have extra costs, but most people browsing the internet will never notice these costs. One place where there might be some noticeable cost is the very first message that you send, because instead of sending the message right away after the TCP handshake, you have to do that whole 6-way TLS handshake before you can send the first message. So there's a little bit of extra waiting time before the first message. But after that handshake, everything should be pretty fast. So that's our efficiency analysis of TLS.